Good morning and welcome to today's T&D World webinar titled Meeting the Load Growth Challenge, Increase Speed to Power, Reliability, and Growth While Cutting Rate Pressure, sponsored by CTC Global. I'm Nikki Chandler, Editorial Director of T&D World with Endeavor B2B. To begin, let me explain how you can participate in the session today. First, if you have any technical difficulties during the presentation, please submit that to the questions window, and our technical experts are here to help you out. Additionally, we do welcome your questions during the event today. We'll answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in those questions at any time. To do so, simply hit the submit or type the question into the question window and on the side of your screen and hit that submit button. To refer a colleague to today's discussion, you can share it on social media or access event resources. Click the icons on the left side rail of your screen there. Also, please be aware that the session is being recorded and will be available on the T&D World website within the next 24 hours. You'll be notified by email when that archive is available. Now I'd like to introduce our speakers for today. First, we have Dave Bryant, Director of Technology at CTC Global, where he has helped lead the development and deployment of ACCC Conductor technology for over 2 decades. With a background in R&D, field engineering, and utility collaboration, Dave has played a key role in advancing high-performance transmission solutions worldwide. Then we'll have Peter Brim, who's Vice President of Policy and Grid Strategy at CTC Global, where he leads strategic initiatives focused on advanced conductor technologies for grid modernization. He brings over 20 years of experience in clean energy, government relations, and high-efficiency power systems with prior leadership roles there at AMSC and Infinia. We also will have Christian Bilczek, Principal at Breakthrough Innovations, LLC, the consultancy he founded in 2023 to advance the integration of clean energy resources and innovative grid technologies. A retired 35-year utility veteran, he most recently served as Vice President of Asset Management and Planning at Avangrid, where he led transmission and distribution planning, asset management, and grid modernization initiatives. And then finally, we will hear from Jay Caspery, Principal at Transgrid Advisors, LLC. He provides strategic guidance on transmission planning and grid operations to support clean energy integration. With over 40 years of experience, including leadership roles at Southwest Power Pool and the U.S. Department of Energy, Jay has helped shape national policy and regional planning efforts to modernize the grid. We have a great lineup today. I'm now going to go ahead and turn it over to Dave. Thank you, Dave.
First of all, big thanks to Nikki and the T&D World team for putting this together. And thank you all for joining us today. We appreciate, we know how busy you are, and we appreciate you taking the time to join us. We'll try to keep things as informative as we can. We'll wrap up quickly and leave plenty of time for questions. As you all know, the grid is under tremendous pressure. We're seeing massive load growth from AI, electrification, and reshoring. And meanwhile, building new transmission lines can take more than a decade, which just doesn't match the pace of today's demand. That's why the fastest, most cost-effective solution isn't necessarily building more lines, it's getting more out of the ones we already have. And that's where advanced conductors come into play. With ACCC Conductor and other grid-enhancing technologies, we can unlock major new capacity within existing corridors. It's what we like to call speed to power. It's about using proven technology to add capacity quickly, boost reliability, and increase efficiency, all while keeping cost and environmental impact in check. So let's take a quick look at what actually makes ACCC Conductor different. At the center, literally, is a carbon glass hybrid core that replaces steel. That single change cuts core weight by about 70%, and reduces the CTE, or coefficient of thermal expansion, by about 90%. What does that mean in practical terms? It means we can add roughly 28% more aluminum without increasing the conductor's diameter or weight. And that extra aluminum translates directly into higher current carrying capability, The result, up to twice the ampacity of a conventional ACSR conductor with far less sag and much lower line losses. That means cooler operation, better efficiency, and longer service life. It's essentially effective for both reconductoring projects and new line builds. Now, I know the industry sometimes debates the value of transmission efficiency, since line losses are usually passed on to consumers, or the cost of line losses. But here's an important point. When you reduce line losses, you're actually freeing up wasted generation capacity. And at this stage, we need every electron we can get. As you obviously know, it's far cheaper to save energy than it is to produce more of it. Here's why this matters so much. Reconductoring with advanced conductors lets utilities double their line capacity without new towers, new land, or long permitting delays. According to the Energy Institute at Haas and several other respected research groups, reconductoring with advanced conductors can meet about 80% of the interzonal transmission needs by 2035. Haas also found that these projects can deliver capacity roughly 4 times faster than new line construction, potentially saving around, their estimate was $180 billion by 2025. Excuse me, by 2050. Personally, I think that estimate might be conservative. I've been with CTC since we started in 2002, and I've seen hundreds of reconductoring projects completed in just a few months. Most were done under maintenance or reliability clauses, which saved both time and money and freed up crews and equipment to handle other priorities. Now, more and more regulators and planners now recognize reconductoring as the fastest, lowest cost path to unlock more power. It's exactly what's needed to relieve congestion and support rapid growth. This is a slide that maybe some of you have already seen in the past. What it really depicts the benefits of high capacity, low sag conductors. In this case, Kinetric's lab ran a span of ACSR conductor with ACSS, INVAR gap, and ACCR conductor. And they ran these conductors up to 1600 amps and then measured the temperature and sag. And what's remarkable is that, considering that the lowest line in the graph represents ACSR, it would have a thermal limit of around 100 degrees. So the sag on an existing line would have been designed to accommodate ACSR conductor most likely. So even though some of the other high temperature, low sag conductors are able to carry twice the capacity like ACCC, what happens is, in many cases, they will actually sag out before they get the maximum capacity. So the alternative solution will be to raise towers. Now, ACCC conductor, and in this case, we also show a gap conductor, they're the only ones that can actually double the capacity without having to change or raise the towers. But what's mostly remarkable in this experiment was the fact that the ACCC conductor ran between 60 and 80 degrees C cooler than the other conductors of the same diameter and weight. So not only can we double the capacity, but we're also reducing line losses anywhere from 25 to 40%, or sometimes even more. That's a remarkable slide. ACCC conductor isn't a concept or a prototype. It's proven, deployed, and delivering results all over the world. Now, I know there's a lot of noise out there. Some folks make claims that just don't line up with facts or even basic physics. What matters is performance in the real world, and that's where CTC stands apart. Over the past 2 decades, CTC Global has helped utilities save enormous amounts of time and literally billions of dollars by delivering the real deal, technology that performs exactly as promised. We've supported more than 300 utilities across 69 countries, and that number keeps growing, and it's not slowing down. Right now, there are more than 80 ACCC projects under construction around the world, and each one helping utilities boost capacity, improve reliability, and accelerate the transition to a stronger, cleaner grid. We're incredibly proud of that track record and even more excited about what's next. Peter, why don't you go ahead and bring us up to speed on what's happening with policy? And thank you, everyone.
Thank you, Dave. A few years ago, our presentation, thank you for the excellent technology overview, Dave. A few years ago, our presentation might have ended here, but the biggest change in recent years is policy is finally catching up to the technology. So some of the things that are happening right now, basically both at the federal and the state level, you're having alignment on policy. Both entities or both groups are driving modernization. They share a unified goal, and the goal is faster grid expansion, the AI race, and the data center growth, and the industrial electrification that Dave described. And he also described the new federal initiative, this Federal Speed to Power Initiative. That is a current administration initiative and a series of executive orders and other policy drivers to drive rapid growth, rapid grid expansion. States are emphasizing grid expansion for economic development, wildfire mitigation, reliability, and affordability. And basically, policy and funding from both state and federal levels are driving unprecedented investment in grid upgrades. On the federal side, federal leadership, obviously many of you probably know about the Grid Deployment Office, where the GRIP program and the Transmission Facilitation Program live, and of course the Loan Programs Office. And contrary to some rumors, there's been a number of announcements on large transmission projects continuing to be funded by the Loan Programs Office. And then many of you are also aware of FERC Order 2023, which happened in 2023 by, I don't think, coincidence, and of course FERC Order 1920, which is a new, very comprehensive planning FERC order. But both of those have specific call outs for advanced transmission technologies and advanced conductors specifically. So federal guidance and federal direction right now is basically to use proven technology and existing corridors to deliver near-term capacity and resilience gains as quickly as possible. That's the driver, speed to power. So at several levels, right now we have, of course, the federal and state require, and Jay will talk a little bit more about this in a moment, but federal and state policy and frameworks now require advanced transmission technologies in planning. Advanced conductors, as Dave described earlier, provide capacity, resilience, wildfire mitigation, and affordability, all in one solution. So again, the policy is starting to catch up with the technology. And utilities are using advanced conductors both on advanced reconductoring projects and new builds. So the last few years, and particularly 2025, the focus has been on rapid capacity growth, and that will continue. But what we'll see next is shifting toward affordability. So basically, the advanced conductors give you the grid capacity growth that you need, and also minimizing costs because of the opportunity to use existing right-of-ways. And I'll transition now to Jay, who's going to talk a little bit more about the implications in planning.
Thanks, Peter. Look forward to this conversation. Thanks to T&D for letting me be part of it. So I'm going to talk about planning. I've been a planner my whole career, and planning has changed a lot. As Peter mentioned, FERC orders 1920 and 2023 have required the consideration of advanced transmission technologies, and some even explicitly require the consideration of advanced conductors. The good news about planning is that I think the grid operators and the transmission owners and transmission service providers are doing a better job at planning, looking at more robust, more holistic scenarios that actually try to take into account metrics that are meaningful and important to not only regulators and legislators, but also to customers and their bills. We've seen a tremendous amount of electrification. We've got a lot of AI data center-based loads that are coming onto the system, and it's going to take a while to build the backbone system to serve those. So we've got to do something in the interim. And the good news is that we've got ACCC as a great solution to help us deal with the needs of the customers to integrate additional loads, additional resources quickly that typically take 7 to 10 years to permit, to get approvals, to get constructed, and we don't have that time. So that's where ACCC and advanced reconductoring really comes in. We've got to also look at things more holistically and consider the total cost to the customer, looking at things that take into account what goes on a customer's bill over the life cycle of the assets that are being approved. Typically, planners and people making approvals about the selection of alternative A versus alternative B are looking at the lowest installed cost. And that may not be the best solution if we're really concerned about affordability. Advanced conductors can be a critical part of our ability to address with these new load additions, as well as the resources that are needed to support the grid in the longer term. One of the things I want to talk about are the tools, and there are some gaps in the tools that we have today. They really don't consider all of the benefits that come from advanced conductors like ACCC. As I mentioned before, losses are really important, and we need to make sure that we fully quantify that impact. There's also, as mentioned earlier, capacity benefits with reduced losses and reduced amounts of megawatts that are basically wasted with the current system. We need to find a way to capture that and use those freed up megawatts that wouldn't be required because we have a more efficient conductor and backbone system to serve new loads and serve them quicker. The dynamic benefits of modern conductors, advanced conductors, are undervalued in our processes. We've got to look at things like the resiliency benefits and the extreme weather events, where the value of advanced conductors like ACCC can be tremendous. And we are required to have that as part of our planning studies and our assessments going forward. And one of the things about advanced conductors is trying to take full advantage of aging infrastructure. If we've got structures out there that are sound and have remaining life, it may make a lot of sense to string ACCC on that wire as a new wire on those structures to accommodate new load additions. We've got lots of new high impact large loads that are being proposed, and some with resources, some without, some that are willing to be curtailed, but they're going to be firmed up over time, and we need to find a way to build the backbone capacity of the system to do that. And we can do that with ACCC. I want to talk about a couple more things before I pass it over. The real benefit, I think, of advanced reconductoring is that we can get this capability and capacity onto the system in a matter of months and not a matter of years. It takes forever to permit, get approvals, and to construct new transmission lines. We've all seen that. And we frankly just don't have the time for that to deal with this push for the AI needs of the system and for national security and everything. But we can accommodate that by stringing ACCC as advanced reconductoring on existing structures that have remaining life, and may help that to be part of the bridge to the future as well as part of the longer term solution. One last slide I want to go through. There's been lots of studies done, not only by the Department of Energy and the independent system operators and regional transmission organizations, that show the need to increase the capacity of the existing system and interregional ties and things like that, not just for local loads, but also for the broader needs to be able to share resources across major weather events, across long distances. And we've got the backbone transmission lines. We just may not have they probably weren't designed for major interregional transmission transfers. And we could accommodate that with advanced reconductors. The good news is, like I said before, a lot of that conductor is old. That's out there on those lines built in the 50s and 60s. And if we were to look strategically at what might make sense in the near term to help address the system needs of our, not only the regions, but interregional transfers, we can do that. There's been lots of case studies out there that have been shown of how people are doing this, primarily for local loads and immediate needs, whether that's wildfires and things like that. But I think there's broader needs, and we've seen that in the studies. With that, I want to transfer it over to Christian and let him talk a little bit about some real examples, and look forward to the questions and answers at the end. Thank you.
Great. Thank you very much, Jay. My name is Christian Bilczek. Start with think this is the wrong slide. Nope, this is good. Today, utilities face a complex balancing act. They must plan for load growth, constrained renewables, ensure reliability, and keep rates affordable, all while meeting regulatory and community expectations. So solutions that expand capacity, boost efficiency, minimize environmental impact, and keep costs under control continue to be needed more than ever, preferably without demanding new rights of way. And as you heard from the prior speakers, this is where advanced conductors come in. Many people think of them solely as a tool for reconductoring lower capacity lines or for extreme long span crossings. And yes, they're highly effective in those cases, but that's not the full story. Because these conductors bring higher strength, lower sag, superior efficiency, they also become compelling for new transmission builds or rebuilds. Let's walk through 3 real-world design scenarios. So first, and the most obvious and compelling, is what you've heard already up to this point with advanced reconductoring. You could take an existing line, same tower, same right-of-way, and you install an advanced conductor like ACCC. Because of its significantly higher capacity and lower sag, you can achieve up to twice the throughput of the same structures with minimal retrofitting. And by contrast, using traditional conductors often forces you to replace towers or rebuilding entire segments, adding time, cost, and disruption. Second, when you need to construct a new line or fully rebuild a line, ACCC gives you the opportunity to rethink the structure and clearance design. With its lower sag and higher strength, you could use fewer towers or shorter towers, and that translates into less visual intrusion, potentially less right-of-way needed, shorter construction time, and lower overall structure and construction costs. Third, there's projects that we know they take many, many years to get from initial planning through design and siting. During that period, often you encounter unexpected loading projections that might change the need for a higher capacity line than what was contemplated and engineered. Suppose you design a new line based on one load forecast, then demand forecasts spike after the initial planning studies and engineering and siting is essentially complete or complete. With traditional conductors, you might have to go back, redesign, re-permit, reacquire land, delay commissioning, and costs and risks go up. With ACCC, you could bolt in more capacity because it gives you the ability with the same footprint, faster, lower cost, with fewer changes. The chart on the left is a good way to think about the trade-offs of different sizing options for ACCC and how it compares to a conductor like ACSR. Option 1 in the upper right of that chart gives you the highest capacity benefit at about the same or slightly higher total project cost compared to ACSR. Much, this is the cases that we talk about, up to doubling the capacity. Option 2 lowers the per mile project cost a bit while achieving a small increase in capacity. And option 3 gives you about the same rating in this case as the ACR that's being compared, but even at a lower cost than option 2. What I have seen for new builds and reconductoring is the potential to save 10 to 15% or more of the total project costs by considering a design right from the start that utilizes ACCC. This is in Alberta, Canada. A new line project was initiated and the project design with ACSR was completed in 2019. In 2023, while pre-construction activities started, it became clear the impact of new generation growth forecasts meant that the capacity of the line was getting ready for construction was too low. It was solved by replacing the planned ACSR with ACCC. It avoided costly redesign, re-permitting, and implementation delays. 1,100 miles of ACCC will be installed with the same prior line design for a 2026 planned in-service date, increasing the line capacity 65% while saving probably 3 years and $30 million or more from an otherwise redesigned line. When we talk about advanced conductors and ACCC, the value isn't just in the capacity they deliver or associated with the lower cost of reconductoring or potentially total project costs with new lines and rebuilds, but it's also how they reduce the physical and visual footprint of a transmission project. By sagging less, weighing less, the advanced conductors have the potential to let you use fewer and or shorter towers. That means less land disturbance, less visible infrastructure, and most importantly, being responsive to community interests. On top of that, their higher efficiency means lower cost. And an overall design that aligns with environmental reliability and clean energy policy goals. And you see some of the headlines that are on the left of this slide. Those are real headlines. The list could go on and on. The visual and environmental impact of transmission lines is becoming scrutinized more than ever. And ACCC gives a very viable option to be responsive to those interests and concerns. All told, choosing an advanced conductor gives us more than incremental gains. It changes the design dynamic. We get higher capacity for the same footprint, shorter or fewer towers standing in the landscape, and more efficient delivery with less wasted energy. In other words, we meet demand, keep community impact low, and do so in a smarter, more cost-effective way. And that makes it a compelling option for today's constrained transmission environment.